Hey guys, great to be back with y'all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. It's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
Hello, and welcome to 5-Minute Math. Today we are looking at the third grade concept of representing addition and subtraction problems. This is standard 3.5A in the great state of Texas. And we're using item number 30 off the 2018 released STAR test. If you have not done so already, please go ahead and take a moment to pause the video, see if you can work this problem out on your own, and then unpause it. We will look at our answers together. So this looks like a fairly complex problem. If you look at the answer selections, F, G, H, and J, they don't have regular equations, but they do have these strip diagrams. So let's just go ahead and label these. You might have heard them before as part-part wholes, and that's fine. Part-part whole is a type of a strip diagram. There are other types of strip diagrams that are not necessarily part-part wholes, so either word works here. So we need to have a picture, a representation of our problem situation up here. So let's see if we can figure this one out. I'll write an equation first, and then we're going to match that to the correct strip diagram. There are a total of 294 restaurants. So when they give you this total right here, I'm just going to go ahead and put A equals 294. Because when they use this word total, that lets you know that that's going to be on one side of the equation. Remember, the equation needs to balance out. We need to pretend like our equation is like a balance, right? And so whatever's on this side, put a little box here, needs to equal everything that's over on this side, even if it looks a little bit bigger, because we're going to have some addition, subtraction, multiplication, division. But we need to balance it out. So of these restaurants, we've got 196 on the highway, 49 downtown, and then the rest. So there's my unknown. So I've got 294 restaurants, and it seems like we're just going to put 196. I can put that kind of in a box here. We're going to put 49 in a box here. And then the rest. So the rest is going to be my unknown. So I'm just going to put a little question mark here. So if I wanted to balance these two out, 196, it looks like we're going to have some addition signs here. So I can write this as a number sentence, 196 along the highway, plus 49 downtown, plus my question mark. Those are the ones on the shopping mall. All of that equals 294. So that's an equation to represent this problem. If we're wanting to find the number of restaurants in the city that are shopping malls, we can start with this and we can use some different equations that use inverse operations, fact families. But we are looking at strip diagrams. So in a strip diagram, this is the number one thing we need to remember. When we're looking at a strip diagram, the whole or the total, if you ever get a whole or total, if that's given to you and one of the unknowns is actually a part, the whole always goes up on top. That's how we do a strip diagram. So we're going to put this right here. So that represents everything. And then underneath it, we already know we've got 3 chunks. Sometimes they try to make them proportional. Sometimes they don't. I'm not going to worry about it this time. I'm just going to say 196, 49, and then question mark. So when I draw it like this, I don't have to include the plus signs because the strip diagram shows you that when you connect these connecting bars are automatically plus signs. And so when you're looking at that, you see there's only one answer selection that actually has the whole total up on top, 294. And so they did make it proportional. They made that 196 much larger than the 49, which makes sense. So our answer is going to be G. Now, why is our answer G and not F, H, or J? Let's take a look at those. Look at what F, H, and J do. First off, F, H, and J all put your total down as one of the parts. They put the whole down with one of the parts. And if you add 294, 196, and 49 in F, or 294, 49, or 294, 196, take a look at these two. 294 and 196, they're way bigger than 49. That doesn't make any sense. 294 plus 49, already larger than 196. That doesn't make any sense. And then all of these 3, we don't know what they're going to add up to, but it's going to be much larger than 294. And we already know that 294 is our total. So our answer is G.
Okay, guys, let's go ahead and look at this problem right here. You follow as I read. The school store had 125 pencils. It sold 45 pencils on Thursday and 40 pencils on Tuesday. How many pencils did the school store have left? Use the number line to help you solve. So we can use a number line. I'm also going to use my cubes to help me understand what we're trying to do here. I'm going to circle important information. I have 125 pencils. They sold 45 pencils and 40 pencils. And what I'm trying to find out is how many pencils. So underline the question. The question is, how many pencils did the school store have left? So that's what we're trying to find out. I'm going to box in some operational clues. Say sold right here. Okay, whenever we sell something, we don't have it anymore, so it's gone. And have left, that's another kind of keyword there. It kind of tells us something. And since it's in the question, I think it carries a little bit more weight to me when we're talking about keywords. So I'm evaluating. First thing I'm going to look at is labels. Okay, 125 pencils, sold 45 pencils, sold 40 more pencils. And I'm trying to find out how many pencils there are. All my labels are the same. So that's kind of telling me it's going to be probably addition or subtraction. Okay, and these keywords right here tell me it's going to be smaller. So they sold and how many they have left. And so that's kind of telling me there's 2 operations that makes things smaller. That's subtraction and division. So I think I'm going to have to subtract. And since I'm doing it on a number line, I'm going to start all the way on the left side. I'm going to put my 125 right here just past 120. So that's my starting point right there. And that's 125. And so I see they sold 45 on Thursday and they sold 40 on Tuesday. Starting to solve here. First thing I'm going to do is I'm going to go back 5 on my number line. And that'll take me back to one of my solid dots right there. That's -5. And when I'm -5, and I'm talking about the amount of pencils that are sold on Thursday, that still leaves 40. So to get to what they sold on, what they sold on Thursday, I have to go back another 40. So I'm going to jump for 120 all the way back to 80. That should be 40 right there. Minus 40. And that gets me to how many pencils they had left after selling pencils on Thursday. And then on Tuesday, they sold 40 more pencils. So I'm going to jump back 40 more, all the way to 40. That's minus 40 again. And that should be how many pencils they have left right there is 40. We'll do it in computation too. I have 3 numbers there, and I can subtract twice, or I can add those 2 numbers together and then subtract it once. And I think that's what I'm going to do. So I'm going to do the 40 plus 45. And see how I did it backwards there, but it doesn't matter. There's a community property of addition. 5 plus 0 is 5, and 4 plus 4 is 8. So that means they sold a total of 85 pencils. Now I can take the 85 from the total pencils they started with, which was 125, and subtract 85. 5 from 5 is 0, and I cannot take 8 from 2, so I'm going to go all the way over my hundreds place. I'm going to take one of my hundreds, and that's going to leave 0 hundreds, and that will give me 12 tens, or 120. And 8 from 12 is 8, 9, 10, 11, 12 is 4, or 40. So that's what we came up with right here. There are 40 pencils left in the store. It matches what I did there, and matches what I did on my number line right there. Okay, let's look at this next problem here. It says Carter plays a video game. He scores 157 points on the first level and 124 points on the second level. What is his total score after the second level? And use the place value model to add. So that's what we'll do. We'll use the place value model to add. And it says right there it's an addition problem. I'm still going to go ahead and evaluate it because we don't, typically they're not going to tell us what we're going to do in a problem, but we'll do a little bit of evaluating of this. So I'm going to, first I'm going to circle my important information, the 157 points and the 124 points. And what we're trying to find out is what is the total score. Okay, and the score is going to be the points also. I'll go ahead and underline the question. What is his total score after the second level? So I'm going to box in some operational clues. I'm going to box in the word total right here. It's right here in my question, so that's kind of telling me something. And that's really the only thing I really need to box in. I'm going to evaluate. Okay, I'm going to use a strip diagram to evaluate this time, or a part-whole model. And I'm going to break it apart. We know that the first score was 157 on the first level. The second level is 124. And right here in the question itself, it says what is the total. So that's going to be the top part here. I'm trying to find out. That's what I'm trying to find out. And whenever I know 2 parts and I'm trying to figure out the whole, that sounds like an addition problem. And it told us right here in the statement that it's going to be addition. So we'll go ahead and start solving it. Okay. When I'm solving addition problems, I always like to start in the ones place, or my units place right here. And if I look at my units, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, but we can't have 11 in the ones place. It doesn't really work out too well when we have 11 in the ones place. So we'll go ahead and regroup there. We'll do some regrouping. So I'll take those 7 right there, and 3 from down here. And that makes 10, and I'll move that over to my tens place and add another 10. So now I have 1 left right there in the ones place. Now look at the tens place. I got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 tens. So that looks like 80 right there. And then I have 1 200s. 1 and 200s. So that looks like I have 281 there. Okay, and we'll go and do a regular computation, the standard way we add together numbers. So that's 157 plus 124. So we add our ones place first. 7 plus 4 is 11. We cannot have 11 in the ones place, so I'm going to take the 10 from the 11, move over to the tens place. And then 5 plus 1 plus 2 is 8. Or 50 plus 20 plus 10 is 80. And then 100 plus 100 is 200. 281. Same thing we got when we used our base 10 blocks or our pictorial model or place value model or whatever we want to call it. Okay, let's go and look at this problem. Follow along as I read. A baseball team has 31 baseballs at the start of practice. During practice, 14 balls are lost in a field. How many balls does the team have left? So what we're trying to figure out is which number line shows the answer. So do our cubes here. First thing we'll do is circle the important information. 31 balls at the start, and 14 balls were lost. Underline the question. How many balls does the team have left? So that's what we're trying to find out, is how many balls there are. I'm going to box in some operational clues. Have left, that's right there in my question. I like that when it's in my question, when I see keywords in my question. Typically, that's what we're trying to find out. We're trying to find out how many balls they have left. And that's a key term for subtraction. So it looks like the problem that I'm going to do to solve, or the problem that we're going to do to figure out how many balls they have left would be 31 minus 14. So what is 31 minus 14? Okay, we'll work it out real quick. We'll stack it up. So 31 minus 14. Can I take 4 from 1? So I'm going to have to regroup from my tens place. That's going to leave 2 tens and give me 11 ones. Then 4 from 11 is 7. And then 1 from 2 is 17. Okay, so using this strategy right here, we could probably look at our answer choices and figure out which one's the correct answer, just kind of based off of we already figured out there's 17 balls left, and I can look at my answer choices and see which one. I say 17 balls left, and see which one answer choice shows 17 balls left. Okay, but we're going to go ahead and take a minute and interpret what the number lines are actually doing. So answer choice A. What is answer choice A doing? Yep, the answer choice A looks like it is 31 plus 14. And that is not what we're going to do to solve the problem. What is answer choice B doing? Yep, answer choice B looks like 31 minus 14, which is what we said we need to do. So we'll put a question mark there, and we'll look at our other questions. What is answer choice C doing? Yeah, answer choice C is doing 31 minus 10 plus 4. And what is answer choice D doing? Yep, answer choice D is doing 31 plus 10 minus 4. So C and D are not the correct ways to solve to figure out how many balls are left. B is our correct answer. Okay, it's time to complete your independent practice. Please complete your Schoology assignment. It will be right after this video, and I'll have something there for you to print out, so you can print it out and work it on paper. But make sure you go ahead and do the blue puzzle piece, which is 3.5A, exit ticket, problem solving with today's date on it. And take your time, do your best. This is what we're using to assess whether you understand the skill or not. And if you do have any questions, though, please email your teacher or send them a message in Schoology. And remember, take your time, do your very best.